So students, in the last class we have seen residues and the problems in residues. So the next topic, Cauchy's residue theorem. This is a statement: if f of z is analytic at all points inside and on a simple closed curve C, except at a finite number of poles z1, z2, z3, etc., zn within C, then integral over closed curve C. This means what? Integral over circle means what? The region is closed. Whatever the region given, that region will be closed region. That's where we are drawing integral over circle. So integral over C, f of z dz equal to, the formula is 2 pi I into sum of residues of f of z at its poles within C. So symbolically we are writing like this. So this is a formula, Cauchy residue theorem formula. Okay, statement. So proof is not necessary. So we have to do the problems. Using the statement we have to do the problems. So see the first problem. Using residue theorem, evaluate integral over C 2z square plus z by z square minus 1 to dz, where C is a circle mod z minus 1 equal to 1. Now first you draw the circle. First you draw one rough figure for the given circle. So what is center here? Center is 1. 1 will be, say, somewhere here. Okay. The radius is 1. So from this center, if you take radius 1, it will touch at origin. And this side it will touch at 2. Okay. You draw one rough figure. Now take that inner function, in the integrand function, you take that function as f of z. Let f of z equal to 2z square plus z by z square minus 1. So we are going to use Cauchy residue theorem. That means what? From the given function, you have to find out the poles, then find the residue of that, then add all the residues. Okay. Then add all the residues which lies inside the given circle. You have to take the poles which lies inside the given circle. Now see here that f of z equal to this function. Now find the poles of f of z first. How to find the poles? You have to equate the denominator to 0, or z equal to plus or minus 1. So two values are there. Now see this circle, given circle, which lies inside the circle. Only one lies inside the given circle. So you have to take only that pole. That minus 1 you can neglect. So z equal to 1 lies inside the circle, and which is what? You see this factor power, you have to see the factor power, not this degree. Okay, this factor power. Power is what? 1. If it is power 1 means what? Which is the simple pole. Simple pole or pole of order 1. Clearly. So z equal to 1 lies inside the circle, which is a simple pole. Okay. Now you have to find the residue for this pole. Residue at z equal to 1. Since it's a simple pole, how to write the residue? Limit z tends to 1, z minus 1 into f of z. Here itself, if you want, you can write like this also. 2z square plus z by z square minus 1 can be written as z minus 1 into z plus 1. Okay. If you write like this, then you can see this power. Power is 1, so it is a simple pole. So write the f of z as like this. 2z square plus z by z minus 1 into z plus 1. So this factor get cancelled. Now apply the limit z tends to 1. So 2 into 1 plus 1 by 1 plus 1, which is what? 3 by 2. So you have only one residue for this problem. Since only one pole lies inside the given circle, the other pole lies outside the circle, you can neglect that pole. Okay, you have only one residue. You have only one pole For one pole we have found out one residue. So by Cauchy's residue theorem, so what is the statement? Into OC f of z d z equal to 2 pi I into sum of residue. Here you have only one residue at z equal to 1. What is this value? 3 by 2. So 2 get cancelled, 3 pi I. This answer. So this completes the problem. And the same problem we can solve using Cauchy integral formula also. That we did in the first topic. The same problem we can solve this using Cauchy integral formula. How to solve that Cauchy integral formula? Let's see here, do it inside of the notes. 2z square plus z by z minus 1 into z plus 1 into dz. Okay. Now how to use Cauchy integral formula? You have to see the factors. On seeing the factor, you have to choose a z naught. In this factor, z naught is 1. In this factor, z naught is minus 1. Which lies inside the circle? 1 only lies inside the circle. Minus 1 lies outside the circle. Which is lies inside the circle, you keep that factor in the denominator. Do you remember? And the other factor you can take it to numerator. Now we can write this as f of z by z minus z naught into dz. Okay, where f of z equal to 2z square plus z by z plus 1 and z naught is 1. Now what is the formula? Do you remember this Cauchy integral formula for this integral? 2 pi I into f of z naught. This is the formula. Okay. So 2 pi I into f of z naught is what? 1. So 2 pi I into, so in f of z, in place of z you write 1. So 2 plus 1 by 1 plus 1. So 2 pi I into 3 by 2. 2 to get cancelled, 3 pi I. Now see this answer using Cauchy integral formula and Cauchy residue theorem. Both are same answer. So if they ask just evaluate, you can use any method. But if the method is mentioned, residue theorem means you have to solve using residue theorem. Using Cauchy integral formula means you have to use Cauchy integral formula. Okay. But if they ask just evaluate, it means, you can do by any method as you like. So which completes the first problem. Now see the second problem. Evaluate integral over C dz by z square plus 4 whole square, where C is a circle modulus z minus I equal to 2. And the same problem we have solved using Cauchy integral formula also in that topic. You can see this problem in the notes also. Okay. Now we can solve this using Cauchy residue theorem. Now first you draw one rough figure for the given circle. What is center here? I will be somewhere here. Okay. Radius is 2. So from this point you have to take radius 2. So it will touch at minus I here. Radius 2 means. Above it will touch at 3I. Okay. You draw one rough circle. So this is minus I, 2I, 3I. Now if you want, you can factor this. What is a square plus b square formula? Already told you. A plus ib, that means 2i into z minus 2i. So z square minus I square is plus 1. So 2 into 2 square is 4. And since whole square is there in the factor, you write whole square in both the factors. So this is f of z. Now write the poles of f of z are, equate the denominator to 0. No need to write whole square, just you write that factor over. So what is z from this? Minus 2i. From this factor, 2i. Okay. Now you see this given circle. Which pole lies inside the given circle? plus 2i only lies inside the given circle. Minus 2i somewhere will be here, lies outside the circle. So you have to take only this pole. So z equal to 2i lies inside the circle, which is what? You see the factor power. You see this factor power, which is a pole of order 2, isn't it? Which is a pole of order 2. Now find the residue for this. Pole of order 2, what is the formula? 1 by 1 factorial. Limit z tends to 2i. D by dz of z minus 2i whole square into f of z. This is the formula for pole of order 2. 1 by 1 is 1, no need to write that. Now write f of z. You write in this form. Not only you can cancel this factor. So z minus 2i whole square get cancelled. Now you have to differentiate this one time. D by dz of this function means you have to differentiate. What is differentiation of 1 by x square? This is of the form 1 by x square. Differentiation of 1 by x square is minus 2 by x cube. Into differentiation of this factor is what? 1. No need to write that. So we have differentiated this. Now you can apply the limit. 2i plus 2i whole cube. 4i whole cube. I'll write here. 4 cube is what? 4 cube is 64. I cube is minus I. Okay. Minus minus get cancelled. 1 2 get cancelled. So 1 by 32i. So we have found out the residue value. Now by Cauchy residue theorem, what is the formula? Integral OCF of z dz equal to 2 pi I into sum of residue. Here also you have only one residue. Residue at z equal to 2i. And the residue value is 1 by 32i. So this I get cancelled, 1 2 get cancelled. So pi by 16. So which completes this problem. So remaining problem we can see it in the next video.